Good afternoon, everyone. I hope that everyone has had their lunch and enjoyed it. Okay, so yeah, as Aditya mentioned, so I'm Rituraj from Bahar Committee. So today a taskbar, you'll see various options like file, application, simulation, etc. So in this, the first and foremost thing that I suggest the team should do is to just refer the user's guide as well as the reference manuals that have been provided by IPG. To access those, what you can do is just go into the help tab and you can just click on user's guide. Yeah. So the user's guide is visible. So basically the user's guide intends to explain how to use each of the functionalities of carmaker that are accessible through the GUI. Okay, so besides this, IPG also provides us with the reference manual. So reference manual contains descriptive information about the different modules that are available in carmaker that are implemented in carmaker and are accessible to using user accessible quantities. Okay, so uh, I'll just like to make a note over here. So like that uh, the teams which will extrapolate as much as they can from the reference manual and user guide will be able to model their vehicles to utmost accuracy as well as to utmost the performance of the vehicles will also be very good. So as Aditya mentioned earlier, so like this year that as the tracks will get difficult, so it is really important that you focus a lot on reference manual as well as the user guide. So I'll also suggest you guys to whenever you're using the car maker GUI, just have your reference manual and user guides along with you so that you can refer any things that you have doubts regarding in the carmaker interface through user manual or user guide or reference manual. Okay. So besides this, in the help tab, you'll also see various other manuals that are available. So you can also go through this as per your requirements. Besides this, I just wanted to add one more thing. So like for the new teams, uh, for the juniors who have just joined the team and are on in the IPG team. So IPG Karmika team in your college. So what they to acquaint them with the software in less time and like creating a CM underscore projects uh, folder, a central folder inside your local disk C wherever your software has been installed, and in that you can create a in that only you need to create all the project folders. So basically the project folders will have all the information regarding will have all the information regarding your vehicle, which has been stored and which will be useful for IPG movie as well as for the simulation runs. Okay. So let's start by creating a project folder over here. So yeah, so right now I've named the vehicle, the folder as a demo vehicle, but like please make sure that you name your folders for the final submission according to the virtual dynamic guidelines that are going to be provided by IPG by BAHA. Okay, so now let's go to the GUI. In this, we'll go to File, we'll go to Project folder. In this, we'll go to Create Project. Okay, so now the new project tab has opened. In this, what you can do is just select this button. In this, go to demo vehicle, which is already the folder that we had created, and just click OK. Now, there are these various options that are available to you guys. So, to get more information regarding this, you can refer the reference manual. So I'll just open the reference manual. So in this, the list of project features has been mentioned. So all the features that were there on the carmaker GUI are over here. So you can select or deselect anyone as per your requirement. So right now I'm going to go with the default option. That is none of them are selected. So I just click OK and our project folder has been created. So like uh, we have crossed our first step. Okay, so now let's start vehicle parameterization. So for that, what you can do is go to parameters and go to car. Okay. So now the vehicle data. So now the vehicle data set GUI is open. So in this, we'll see various tabs like assembly, body, suspension, etc. The manner in which you parameterize your vehicle in IPG carmaker is that you like add the masses, the inertias, the different parameters, performance parameters in all these tabs, and then all the information is consolidated, and a virtual vehicle is created in the IPG carmaker software. So to start with, like you can also use the vehicle data set generator tab. Okay. So the vehicle dataset generator tab is a simple way to create a vehicle in IPG carmaker to start with. Okay, so in this, like in the vehicle class, just select small car. So like this is we are selecting small car because like the dimension, it is the category of vehicles which has the smallest track width as well as wheelbase dimension. So and the properties are similar to Baha vehicle, not exactly similar, but that is the closest that we can get to. So just select the small car and vehicle class. Now, besides this, you can add other vehicle parameters. So like unloaded weight, vehicle length. So vehicle length over here is basically the distance between the frontmost and the rearmost point on the vehicle. So for example, if your like if the tires are beyond if your tires are going beyond your chassis, so basically the frontmost point of the front tire to the rearmost point of the rear tire, so that would be the vehicle length. Similarly, vehicle will be the same thing in the lateral direction. Okay, so the vehicle height will be the distance between the ground and the maximum height of the vehicle. So in the case of Baha vehicles, it can be set the FBM that we have in a roll cage. So the uppermost point of a roll cage. So wheelbase is pretty understandable. So you can enter that according to your design. The track width front and track width rear can also be added. So besides this, there is also rare overhang. So you can also like find the definition regarding this in the user manual, and you can enter these parameters according to your design. So besides this, you can also select a tire size over here as per your dimensions. Going on to advanced settings. So in this, like over here, you can parameterize the vehicle much more by using more parameters. Okay, so for example, like starting with vehicle body. So the generated vehicle can have either a rigid or flexible body model, which allows bending and torsion of the main body. So basically, if you don't want to allow bending as well as torsion in your chassis in your vehicle body, just select rigid vehicle body. And if you want to allow that, you can select for flexible. Okay. Then the driving axle over here is the axle which has the which is driven. So basically, in case of a rear wheel drive vehicle, so in which the CVT is coupled directly to a two-stage reduction gearbox, you can write rear wheel drive. So now, like since last 2 years, so like a lot of teams have also shifted to all wheel drive or four wheel drive. So you can also select all wheel drive option over here. And gearbox, depending upon the type of gearbox you're using. So basically, if you're using a manual gearbox, you can choose the manual option, or if you're using CVT, you can choose automatic option. In steering, the parameters like turning circle and max steering angle needs to be added. So turning circle can also be set as turning radius. So you can add those parameters over here. As the like in case of MBA, so the engine is provided by Briggs and Stratton, so it is same for everybody. So you can add the nominal values. Like for example, I'll just add. Uh, okay, so basically, like you can add these values according to the power curves that have been provided by Briggs and Stratton. So in transmission, you need to specify the number of gears and the spread of gears. In axle suspension, you can specify the ride frequencies. And the last option is aerodynamics. So in aerodynamics, the drag coefficient needs to be mentioned. So in case of Baja vehicles, like aerodynamics isn't that uh, relevant to the vehicle performance. So as the vehicle speed is not like up to that limit, so where air like air air drag can be felt is and it is hampering the vehicle performance. So in this you can keep this as default only, so there is no need to parameterize this. Okay, so now that we have created this vehicle data set, so we can just just a minute, I'll just add a few reference values. So these are default values. So you'll need to add these values according to your design. So I'll just generate the model. Okay. So now we have received a warning. So like the data out of range, unloaded weight 150 kgs and vehicle length 1400 mm. So such kind of warnings will definitely come. So as IPG carmaker is a software package that is like designed for commercial vehicles, such kind of values aren't expected. So and as I said, like the small vehicle model is as close that we can get to the commercial side of things. So basically over here you can just continue with the data, so no issues with that. Just close the. Okay. So now in the main assembly tab in configuration, so you can see that the description has been generated for the vehicle that we had created. So in this, you will see all the parameters that we had added. Okay. So coming on to configuration. So in any software package. So a reference frame or the coordinate system is extremely critical. So same is there with IPG carmaker also. So in IPG carmaker, so there are various reference frames that are used to model different systems. Okay, so like over here, you need to specify vehicle FR1 reference frame. So that is the most uh, the like most important reference frame. Okay, so I'll just go to the reference manual. Okay. So yeah, in this, like as I said, there are various reference frame available in carmaker. So starting with FR0. So FR0 is the Earth fixed origin of the virtual world. Okay, so then there is FR1. So the reference system that is mounted on the vehicle. It is mounted at the rearmost point of the vehicle. Okay, so like to understand what is FR1 in case of Baha vehicle. So what you can do is that you can just imagine that there is a uh, imaginary plane tangent to the rearmost point on the rear wheels, and it will be at the center of that plane. Okay, so just, uh, just open the user guide as well. Okay, so as I mentioned, like it will be at the center point at the rearmost point. So in case of Baha vehicles, so the rearmost points, if you put a plane from the rearmost point on the tires, you can find this FR1 system at the center of the track width, rear track width. Okay. So moving on, so there are various other reference frames as well. So one of the most important ones are FR2 as well. So FR2 is the wheel carrier fixed reference frame. So the origin is defined at the wheel center position in this reference frame. So we'll also explore other reference frame as and when like we are doing the vehicle parameterization. I'll open the car maker here. Hello, Aditya, is my sound audible?
Yes, yes.
Okay, so there was just a bit of lag in my laptop. Okay, so yeah, so coming back to vehicle dataset. Okay, so the next tab is engine mount. Okay.
Yes, just a moment before we move on to the next, like the engine mount, regarding configuration, what Ruturaj said. So one thing what you as teams can do is like first to minimize the time to parameterize of car, you can create a CAD model of your entire vehicle. As you can see, that entire calculations of the like in the software will be done based on the reference frames. So it is of paramount importance that those reference frames be entered as accurate as possible. So if you have created a complete vehicle model in your CAD packages, so you can create multiple coordinate frames in that, and if you and you can try to correlate the same values with your CAD package. And in this way, you can try to minimize the time to completely parameterize the car, even if you have used some different reference frame. Okay, Ruturaj, you can go ahead.
Yeah, so and adding on to Aditya's point, so in a lot of CAD packages that are available, so the reference frames might be different in which you're creating your CAD geometries or the CAD assemblies. So just make sure that you are taking that into consideration while parameterizing your vehicle and IPJ car maker. Okay. So moving on to the engine mount. So in engine mount, there are two mounting positions that are available. So the mounting models that are available, that is rigid, rigid, and the others are like the flex, elastically mounted mount. So basically, in the rigid mounting type, so the elastically mounted engine is disabled. So basically, in case of Baha vehicles, so just consider this thing like the engine will be directly mounted to the chassis. Okay, so there won't be any damping material or there won't be any bush that is connected to the engine, and it will be there won't be any so which makes the mount as elastically which in this case like elastically mounted engine will be disabled. So the other case will be if you're using like bushes like for which are made of materials like polymers or rubber and such kind of material. So you can parameterize that using the other three models. Okay, so like generalized joint force and the explicit force elements. So coming on to a generalized joint force. So in this, there are various modes that are available to the user to model the mountings. Okay, so model the stiffness of the mountings. So right now it is Kelvin word. So there are other options like DVA and user function as well. So I'll just go into the reference manual ones that we can explore this furthermore. Yeah. So like as you can see over here, so like the FR engine frame and there are various force elements at the points where the engine is mounted onto the frame. The user elements. Okay. So as I'm like the information regarding these modes can be found out in the user guide as well. So and this like for example the Kelvin word as well as DVA as well as the user function. So Kelvin word model is used to model non-linear spring and damper characteristics of the mounting. Okay. So you can understand what kind of modes these are using the user guide and referring to the engine mount section. Let's go back to the carmaker Jira. Okay. So like now that we have selected the Kelvin word model, so in this you can model the stiffness as well as the damping parameters of the mounting. Okay, so like these can be defined by the team itself, and just ensure that you these values are pretty accurate, because if you're just adding like random values or like inaccurate values, so the accuracy of the model will decrease. So rather than going for this, it is better to go for rigid mounting if you don't have accurate values of stiffness and damping. Okay, so after that, so there is this amplification factor over here. So the amplification factor can be used to multiply the values of stiffness and damping. So basically, if I, for example, if I choose the value of 2, over here, the values will be multiplied by 2. Besides this, there is this length IO option in which you can enter the unstretched length of the mounting. We'll explore this furthermore in suspensions where it can be easily understandable by the team. So right now I'm just unticking this box and going for rigid only. So and just a suggestion from my side as well. So like it is better to keep the engine frame, reference frame FR1 as these default values only. So it will be better to parameterize the entire vehicle. And one more thing that I missed out was that while if you use the rigid mounting, so the frame engine isn't activated. It is only activated if you are using any of these three models, remaining three models. Okay. Going on to body. So the body, uh, the body tab can be used to parameterize the positions of hitch, jack points, and the point of attack of virtual forces. Okay, so all the hitch point dimensions can be parameterized using this body tab. So this isn't this won't make any difference in the vehicle performance. So it's up to you that what you want to do, but yeah, it's better if you parameterize this. Coming on to chassis, so in this you will be able to see various different wheel carrier and wheel namings. So basically, like wheel carrier front left, wheel carrier front right, as well as same for the wheel as well. So like I'll just show the graph. So the graphic tab can be used to visualize these bodies, uh, the IPG carmaker board. This. So in this, you can see these red dots. So this is basically the wheel. So whenever you are adding the positions over here, so you are parameterizing the center of the wheel. So similarly, you can also you can also see the other coordinates that are mentioned in the GUI and take reference according to that. Okay. Yeah. So just for the uh, people that like who don't know about this, so like wheel carriers is basically the wheel assembly. So the upright and the wheel up assembly. Okay. And wheel is pretty basic. So yeah. So in this, you will get the options like we'll start with wheel carrier. So in this, you'll get the options like mass and moment of inertia. Okay, so the thing that needs to be noted over here that in wheel carrier, unsprung but not non-rotating masses should be added. Okay, so for example, wheel carriers, brake calipers, rods, or other fixed elements whose weight pushes on the wheel carrier should be added over here. Okay, so now there are a few elements which are like kind of half unsprung. For example, the steering rod. Okay, so what you can do is that for such kind of elements, you can just only add the half of the weight in wheel carrier. Okay. The moment of inertia of the wheel carriers can be stated over here. So you'll get these values from, you'll need to get these values as per your designs. Like if you want to add relevant the products of this moment of inertia. So you can just click on this arrow, and over here you can add the product of inertias of all these product of inertias. Moving on to the wheel. So in wheel, you can like as I mentioned in wheel carrier, you need to specify the unsprung and unsprung but non-rotating masses. In wheel carrier, in wheels, you need to mention the unsprung and spinning masses over here. Okay, so for example, wheels, then disc brakes, etc. Okay, so you just make sure that you are adding these masses accordingly to this definition. So you can also get more information regarding this in the user guide. Okay. So similarly, you can also add the moment of inertia of wheel also. So coming on to powertrain. So in powertrain, there are these various options that are available. So for different drive sources, different subcomponents are there. So like for example, in drive source 0, there is engine, gearbox, electric motor, gearbox M, and tank. So we'll explore this things again in the powertrain modeling. So like, but just now, like we'll focus on engine and gearbox. So regarding this, you need to ensure that you're choosing the reference frames accordingly, so that there is no like issues in parameterization. So to understand which reference frame should be selected for which model, which subcomponent. Let's go to the user guide. Okay. So in this, in the powertrain section, you can see like all the reference frame that should be selected are being mentioned. So for example, the engine and gearbox can alternatively be mounted to FR engine. Okay. So so now, like, if you notice, like the mask column is disabled right now, so I am not able to enter any values over here. So how will I enter the masses of these components. So for this, what I can do is I can just go click on the arrow next to it, and I'll be in this powertrain tab, in which I'll be able to add the masses. So for example, I, I was in engine, so I'll go to bodies and I'll add the mass. So a thing to mention over here is that Baha also provides you with the IPG carmaker guidelines. So right now I have taken these values from the guidelines that were provided last year. So the 2022 seasons guidelines. So uh, so these are the default values that were uh, told to be used last year. So please use these values according to this year. Okay. So which will be launched soon. So the guidelines will be launched soon. So please refer those for these values. So similarly, the inertia of the engine can also be specified over here. So now that we have added the mass of the engine, so let's go back to assembly parameters, which can be done using the tab. Similarly,
Just a moment, Ruturaj. So here we've received a question like where to find the reference manual and user's guide. So if you open the car maker main GUI,
yeah.
yeah. So
So
teams, if you can see the help tab,
just a minute.
yeah.
Yeah. So I basically like in the main carmaker GUI, so you'll get this help tab. So on this, just click on this, and you'll get the user's guide as well as the reference manual from here. Also, if you refer to the mail that has been provided by Baha, we have also attached this over there also.
Yes, and along with this, the last year's guideline were shared to you along with the licenses email. So you can see the last year's guideline for use for temporary use, but the all the parameterization for the final vehicle submission has to be done based on this year's like guidelines. Ruturaj, if you can open the last year's guidelines just for a
Yeah,
moment.
just a minute. Yeah, so
Yes, if you can go to the next page. Scroll up. Yes. So here, like every manual, every name of manual and what is its usage, that has been given in detail. So just if you can just to do a for a summary, you can see what, like for instance, the user's guide as well as the reference manual, what all is included in those specific manuals. You can just refer to the IPG carmaker guidelines, which is provided by Bahasa India. Yes, Ruduraj, you can continue ahead.
yeah. Yeah. So now that we have, like similarly, you need to parameterize the other components that there are in your powertrain system. For example, you'll also need to parameterize the gearbox, electric motor, gearbox, and tank. There's a tank means fuel tank. So just one thing that needs to be I'll just specify this. We'll cover this later on also while powertrain modeling. But over here, just ensure that you don't add the gearbox value. Okay, so basically, gearbox in IPG car maker. So we add it as CVT, not as so in case of rear wheel drive vehicles, it is you don't add it as two-stage reduction gearbox. Okay, so we add those things in the drive line. So just ensure that you don't confuse this thing with these things. Okay, so I'll just go back to the assembly parameters. Okay, so now similarly, you can model the rest of the components also. So going on to the trim load. Okay, so in the trim load is used to add additional weights like miscellaneous weights to the vehicle model. Okay, so for that, just click on this checkbox and you can unlock this trim load. Okay, so what I'll do is I'll just write driver over there. Okay. So basically, in the guidelines, if you refer the last year's guidelines, so that you need to add the mass of the driver in trim loads as 75 kgs. So just ensure that you do this because uh, uh, this is a thing that needs to be done by default by each and every team. So just I'm specifying once again, like please ensure that you are using the guidelines. You're referring to the IPG car maker guidelines because a lot of the parameters will be specified in the guidelines itself, which need to be set as default. Okay. So for example, that like let's go to trim loads. So in this, you'll see that the driver weight is fixed for all teams and should be defined as 75 kgs. Any team found guilty deviating from the same shall be penalized. So to ensure that you don't get penalized for such things, please ensure that you follow the guidelines accurately. So let's go back to trim load. Yeah. So now that you have you're done with trim loads. So also you need to specify the positions and moments of inertia over here. So in sensor mounting, like you can add the sensor mountings using the view plus option over here, and you can just parameterize its position and orientation and the body mounting frame. So according to your requirements. So like guidelines regarding the sensors will be launched during the times of submission in the virtual dynamic event guidelines. Okay, so just refer for those guidelines for this information. So now that we have created our assembly, so to gain overall knowledge, so we can go into info and just verify these parameters right now itself, so that we don't make mistakes going further. Okay, so as Aditya also mentioned, so the timeline is extremely critical right now. Like as the especially for the MBAR team. So right now you might be in the manufacturing phase, and as well as you have to prepare for your virtual dynamic event. So just ensure that you make minimum mistakes, you spend minimum time in vehicle parameterization. So the tools like vehicle information are extremely useful in such cases. Okay. So like having done with that, let's go to body. Okay. So body, there are three tabs. So structure, outer shell, and aerodynamics. Okay. So like let's select structure, and in this, so the models types that are available are so rigid and flexible. So what is rigid model and what is flexible model? So basically, the rigid model, the vehicle body consists of one rigid mass in rigid vehicle. Okay, so the body won't be separated into two parts. Okay. Whereas in flexible vehicle, the vehicle body is divided into two masses connected by a rotational joint with a parameterizable stiffness. Okay, so just to give, what I'll do is just select flexible. So in this, you will be able to see this image that is there. So just imagine that like this is valid more in the case of commercial vehicles, and it is not valid for Baha vehicles. But like just imagine that there are two bodies which are connected using a rotational joint. Okay. So you can also gain more information regarding this using the using the reference manual. Okay, so as I was mentioning earlier, so like this is very this is the flexible vehicle model, the structure of flexible vehicle model. So vehicle body part B, vehicle body part A, and which is joined using a rotational joint. So where bending and torsion of vehicle body can be simulated. Okay. So again, if you want to simulate these kind of the bending and torsional properties of the vehicle body, you can choose a flexible option. Yeah. So you can choose the flexible option. Just don't select the manual body split. So what is manual body split exactly? So basically, like a manual body split, so there will be two main bodies that are parameterized separately for each of the bodies. So A and B. Basically, as over as you can see over here, so consider that these are two bodies, so body A and body B inside the same vehicle body. Okay. Which and they are parameterized differently. So you can see once I click the manual body split option, so you can add different masses, different inertias to both the options, whereas it wasn't available in manual body split. So if you want to like see the effects of torsion as well as bending of the vehicle body, and like see it's how it affects your performance. So you can choose the flexible model, but just ensure that you are adding accurate values. So because like if you just choose flexible, it might happen that it will give less accurate results in comparison to a rigid model. Okay. So to parameterize this, like you can this you will have different parameterization, so like stiffness and damping. So you can model the stiffness using characteristic value or 1D lookup table. So you can just mention these values over here, and like similarly you can model the damping as well. Okay. Yeah, so again, the amplification factor is mentioned over here. So as I mentioned earlier, so it is just to act as a multiplier for the values that you have mentioned above. So it is a way to enhance, like to reduce your vehicle parameterization time or vehicle tuning time, basically. So which is extremely critical considering the timeline that we are following for MBA especially. Okay, just a side note that I like to add over here. So once you have like fine tuned your vehicle body, for example, you were able to fine tune it at an amplification of 5. Okay, so like okay, so just use that you don't add amplification value as 5 over here in the final vehicle submission. So just ensure that all the values that were multiplied, just ensure that you multiply this by 5 instead of adding the amplification over here. Okay. So the final vehicle submission model should have one in all the amplification factors across the vehicle model. Okay. So moving on to outer cell. So like
Just a second, Ruturaj. Before we move on to outer shell, if you can go to structure.
yeah.
Yes, so the mass here, which is given in body, so it includes all the masses which are not included in any of the other modules. Like for instance, since you do your parameterization in different sections, for instance powertrain masses are added in powertrain section, similarly a few masses are added in assembly section. So just make sure that they are, and so adding all these masses uh, and your this mass which is in structure, body structure, so this entirely gives you your total vehicle weight. So just make sure this is the adjustment factor. Okay, so in case of EVA team, so you can leave the engine weight as 0 in the assembly tab, but in the body tab, you have to adjust your like battery as well as your motor package weight. So if those are grayed out there, and you have to adjust it in the mass and cages field, which is shown in this, where the pointer is currently pointing. I hope that is clear. And just to check that the mass is correct. If Rutra, if you can click on the info tab. Yes, so here the overall mass is always present. So you can close this as well as you can go to the assembly tab for us just a brief moment in configuration. Yes, so here also the overall mass is always present. So just make sure that your entire vehicle mass comes like is always like is equal to whatever is parameterized here. So just make sure that the body mass which you enter in your body tab, it is an adjustment factor. So just a quick highlight on that. You can continue with the outer like the OBJ section.
Yeah. So, like, I just like as Aditya's touched this point, so I'll just like to also add one more thing to that. So for example, as Aditya was mentioning, that we need to add a few things again, like we need to adjust the mass over here. So, for example, if in steering we have chosen the steering static steer ratio model, and this you will see that there is no mass or inertia properties that need to be added over here. So, in such kind of scenarios, you will need to go back to body and you need to adjust this value to the steering subsystems weight also. Okay. Yeah.
like just for example, like in terms of quantities, if you want to say, if your vehicle weight is 150 kgs, and while parameterization of your like specific models, if in your assembly tab, if you're adding weight of your wheel assemblies, in powertrain, if you're adding the weight of your engine, gearbox, so if that comes down to 50 kgs, but still the other 100 kgs is still remaining, so you can enter that 100 kgs here. So that your entire vehicle weight is 150 kgs, and then added driver weight is 20, which is 75 kgs. That can be included, and you can see that in the assembly tab. Yes, sir, go ahead.
Yeah. Okay, so moving on to outer shell. So in this, like you can like specify how the vehicle will look basically. So for this, like we have provided the guidelines regarding OBJ in the IPG carmaker. So there is a separate section for there's a separate section for OBJ file creation in outer shell part. So like you can generate the OBJ file using this procedure. So just refer this to create a new file. Okay, so now I'm going to just select the file right now, and I'll just tell the teams regarding the rest of the things. So basically, like now that we have created our OBJ files. Okay, so basically this is the MTL file as well as the OBJ file. Okay, so what you'll need to do is that you'll need to copy this and add it to our project folder. And also you need to add that in movies. So and one thing that you need to ensure over here is that the name or the file name should match your project folder name. Okay, that there is no issue in that. So now, besides that, you'll also need to attach the top view and the side view of your vehicle, the pics data. Vehicle. In this, you'll need to go in the data. This you'll find the pic folder. So you just add, paste it over here. Okay. So now let's go back to carmaker GUI. Okay. So now that we have copied our our files to the project folder, so now the only task that is remaining is to select those. Okay. So to select, you can just click on this option, and this you will see that the option is available. Similarly, okay. Okay, so now that like after uploading these files, just ensure that you click on this gear icon or create vehicle graphics icon. So you'll be able to see your vehicle over here. Okay. So in this, like also you can like parameterize the bounding box over here by changing these positions according to your vehicle model. So going on to aerodynamics. So like teams are free to explore this option, but as I previously mentioned, so like uh, there is aerodynamics doesn't hamper the performance of Baha vehicles to such an extent that it should be modeled. So basically, you can explore this, but in the final vehicle model, you need to ensure that you keep this as default. Okay. So moving on to suspensions. So I guess
Okay, just a side note here, before we move on to the further like parameters in the body section. If you can go to the body section, Ruturaj. Yes. So first for the outer section, uh, just a quick highlighted note that the OBJ file, it is just a visualization factor. So what we have seen teams do throughout in the past 2 seasons is they have focused their entire time on the OBJ creation. So you and or like optimization of the OBJ, which takes about much more of the time. So we insist you that try to keep your OBJ as small as possible. Even if in terms of graphical representation, you can delete all the internal geometries which are not visible from the outside. For instance, whatever the smaller uh, like aspects of engine are present in your CAD files, you can delete those and you can just keep a outer shell of the engine. So because OBJ is just a visualization factor, so just make sure that you don't invest much more time on OBJ creation compared to the vehicle parameterization. So this is to let you know that. Second, regarding the aerodynamic section, so we would encourage you to go ahead and explore the aerodynamic section like completely, and like you can select the option like as it is mentioned in the carmaker guidelines of this year, which will be released soon. Okay.